I have right here a digital circuit breaker finder. This is a device that has two ends. You connect one end to the socket, and with the second end you go to the breaker box and you can find out which breaker the first device is connected to. This is the part that we connect to the socket, and with this part we search for the correct breaker. On the top there's the company name ET32, the name of the device, EU version, and on the back we have a space. Detection distance up to 3 centimeters. 90 to 120 volts or 200 to 230 volts voltage range, American, European, and British. GFCI test with trip time. We can test if the GFCI is working and how long it takes to trip. It measures voltage between hot and neutral and also between neutral and ground. It shows the status. It indicates if the hot is open, if hot and neutral are reversed, if ground is open, or if hot and ground are reversed, showing whether the wiring is correct or incorrect. It has a learning mode and a standard mode. The battery level can range anywhere from 0 to 3. And for CV it operates between 90 volts and 1000 volts. The battery itself is approximately 3.7 volts. With its battery you can adjust table sensitivity, lighting, and it operates in temperatures up to 50 degrees Celsius. Relative humidity. And what do we get in the package? So let's unbox it and test its performance here. We have a very nicely designed box and an instruction manual. Inside the box we have these two specific components. Here is a USB-C cable for charging the devices, and since I have the European version, I also have a European plug. But as you can see, the device is universal. If you have a different cable, you can use the same device with other sockets as well. And we just plug it in right here. In the manual, we have the correct wiring states: open, ground, hot and neutral, reverse, open, hot, hot, and ground reversed, hot on neutral, with hot open and GFCI. Testing in progress. And when we are locating the breakers, we should perform 2 scans. For the first scan, ignore audio and visual prompts. This is the system's learning phase, and then proceed to the second scan. When approaching the target breaker, the buzzer frequency increases upon successful location. It emits a continuous sound and the status light remains illuminated. And we can switch between sensitivity and IE modes for detecting the breakers. And to test the device, I prepared a sample breaker box. This box was supposed to be for 6 units. I had to improvise a little bit to fit 6 units right there, but somehow I managed to fit them. It has 4 sockets. Each socket is connected in a different way to test different scenarios. The first socket is connected directly to this input plug. The second socket is connected to the first breaker. The first socket is connected to this breaker and GFCI combo, and the last socket is connected to the breaker that is connected to a GFCI. So 2 separate devices. And we will see if I will be able to detect the correct breakers for each socket. And we will test the GFCI to see if it works and what time it will display. All breakers are turned on. Let's start with the left socket. I think this is the most common situation where you have a separate GFCI and a separate breaker. Let's turn on one part and then let's turn on the second part. Both are ready. Right here I can see 230 volts with correct wiring. Let's try to create incorrect wiring and see if the message changes. I've switched the neutral and hot wires and now I have incorrect communication. Hot and neutral are reversed. And when I press this button once, I can see that between neutral and ground there is a voltage of 225 volts. Let's try one more thing. I will try off-grid energy storage because those devices often have split phase. It generates voltage both between hot and ground and between neutral and ground. And between live and neutral there is 230 volts. But also between neutral and ground there is about 120 volts. And because this meter can show the voltage between neutral and ground as well as between neutral and hot, we should be able to see whether the output is correct or if the voltage is split between neutral and hot. So let's change the connection. Now it is connected to the off-grid power source, We have an open ground indication because it is not grounded now, it's off-grid. We have 230 volts between neutral and hot, but let's check between neutral and ground. And we have 120 volts, so we can easily check off-grid power sources to see if they have 230 volts between live and ground, or only between live and neutral, a useful function. Let's go back to the correct power source. Now that we have the correct wiring, let's try to find out which breaker this device is connected to. Now it is in learning mode. We can see the blinking diode, so let's do two passes. First the learning pass, and second the searching pass. The first pass is now officially done, so let's take a moment to see if it is correct, and as we can see, it is indeed correct. And here it stops blinking. When I go to those three breakers right here, it is beeping. It correctly shows that these two breakers are currently linked up to this device right now, and those other two are not connected. Switch off. It stops beeping when I turn off the breaker. And if I turn off the second one, it also stops beeping. So we detected it correctly the first test. Now let's test the GFCI button to see if it works and measure the GFCI. Breakers are turned on. Let's try the built-in tester. It's working, the GFCI. Now let's wait for it to turn on. And now it is showing 0 volts between neutral and ground because this is the current connection. And here we have 230 volts between neutral and hot. And let's try this GFCI button on the device. It tripped the GFCI and we have a 0.1 second trip time, which is correct. When I turn it on, it shows voltage again, so the tester works. Let's go to the second socket. The second socket is connected to the combo device, which is both a GFCI and a breaker in one. Let's do the learning scan. Alright, now let's do a second pass to find the correct circuit breaker. Here, it is not beeping on the last one. Here it is beeping. Here it is beeping. Here it is still beeping. But right here it is not beeping. So this breaker is not the current one because here it is not beeping. Here it is beeping on both sides of this breaker and GFCI combo. And on this GFCI, it is beeping on one half, and on the second half, it is not beeping. So I can be pretty sure that this is the correct device. If it were properly connected, it would start blinking on both sides, not just on one half. They are much closer to this one, and if I turn it off, it stops its beeping sound, so this is definitely the correct circuit breaker. Let's test the built-in GFCI. The GFCI is working. Let's test the GFCI right here. It also trips the GFCI in 0.1 seconds, so it is working correctly. Let's go to the next one, which only has a regular breaker, no GFCI, and let's do the first pass. And now the second pass. This time there's a problem. It's showing those two breakers. Let's turn this one back on, but it's not beeping with this one. Here, it's not beeping. The second one is beeping. The third one is beeping, but this breaker is not beeping. Let's try the manual detection mode without the AI. Now it's beeping in front of each one except the correct one. So in this situation, it has a problem. To make sure that it is connected to this one as it should be, Let's turn it off. So it is beeping. And it stopped beeping. For some reason, it didn't pass the third test. The single breaker without the GFCI, it is beeping for the two GFCIs next to it, but this socket is not connected to them. It passed the first test. Maybe in a large breaker box it would indicate an area around this breaker, so it would still be helpful, but this time it didn't show exactly which breaker was correct. It showed the breakers next to it, and the GFCI button shouldn't do anything because there is no GFCI connected this time. We can see it is testing, but it's not showing the time above 6 seconds. So there is no GFCI, or the GFCI might be faulty. And let's try the last socket, the one that isn't connected to any breaker, and see if it detects anything. Nothing. Just a single beep. But it shows that this socket is not connected to any of those breakers. That's also useful information. And let's test this NCV, which should indicate that the cable is live. Now I switch from scan to NCV, and I can now detect any electrical cable that is currently live. And this device also has a built-in flashlight. It's easier to point at the breaker box in a dark room with a flashlight built into the front. So, a simple but useful device. It passed 3 out of 4 tests for finding the correct breakers. And it also passed the test for detecting the correct wiring. And it also passed the test for checking the GFCI. So only one error, everything else worked perfectly as it should. And here we have the USB-C ports for charging these devices. And you can find the link for this device in the description. And that's all for today. Like, subscribe, and be nice.